Okay, now after completion of our first lecture, in our first lecture we have completed what are the topics. Introduction we have completed. In the introduction, we have done about the units of pressure, volume, temperature. In temperature, 3 scales, volume 4 units, pressure 6 to 7 units. Okay, and the types of manometer and Boyle's law we have completed. And already we have a DPP given on the Boyle's law and it is solved also. Okay, so now let's start with the Charles law. We have to start with Charles law. So as we have 4 variable: pressure, volume, temperature, and number of moles. There are 4 variables that can be related in the gaseous laws. So what the Boyle's law have done? The Boyle's law have related the pressure and volume. Now it is the turn of the Charles law. So during the Charles law, what we will do? Volume and temperature relation. Every law gives a relation between any of the 2 variable. Okay. So that 2 variable, once we are relating, the other 2 variable will remain constant. So like during the pressure and volume relation, temperature was kept constant. Therefore, it was called as a isothermal or isotherm. The graph obtained is called as a isotherms, and this will be at for a given mass of gas. So that means N is constant. So during the Boyle's law, temperature and mass is constant. So obviously for Charles law, where we are relating the volume and temperature, then the main thing which will be constant is pressure. So for a given mass of gas at constant pressure, so once pressure is constant, the graphs obtained in this law are called as a isobar. Okay, bar is a unit of pressure. So bar is a unit of pressure. Therefore, once it is maintained as a constant, then the graphs obtained are called as a isobars. Okay, so isobar, I think it is clear now. Now, according to isobar, and what is the relation? Okay, for a given mass of the gas, here it is clearly mentioned, for a given mass of a gas at constant pressure, volume of any gas varies directly with absolute temperature. This is not some word which is directly used. Absolute temperature means already we have understood regarding the absolute word meaning. It is the temperature in Kelvin. Okay. So this is mathematically, here we are saying volume directly proportional. V directly proportional to T. So, but what is constant here? N and P is constant. Therefore, V by T is equal to constant. What is constant? V by T is equal to constant. Okay. So now for V by T is equal to constant. So let you change the volume. There will be change in temperature. So V1 by T1 also constant. V2 by T2 also constant. Provided what are the things constant? P and N are constant. P and N are same. Okay. So once both are same, then we can relate both of them together and write it as a V1 by T1 is equal to V2 by T2. Okay. Now see here, both are directly proportional only, but this variation you can see like this. This variation you can see like this. Okay. So, but how to identify which pressure is more, which pressure is less? So here P2 is less than P1, but questions, if this type of question comes with the changed value, you should know the approach of graph questions. Okay. So how to approach, see here, but before that you should know the ideal gas equation. So ideal gas equation is equal to PV is equal to nRT. That we will discuss further, but to understand this graph at this point of time, I have to use this. Okay. So P1, PV is equal to nRT. Therefore, we wanted that V and T graph. Okay. So V is equal to nR by P into T. V is equal to nR. So when you compare it with Y is equal to mx. So on the x-axis temperature, you can find it here. On the x-axis temperature is there. On y-axis volume must be there. You can find it here. Volume is there on the y-axis. So that means slope is depending on number of moles and pressure. Okay. But here question is about the pressure. We can see that slope is inversely proportional to pressure. What is proportional? Slope is inversely proportional to pressure. That means low slope, high pressure. You can see here, this is more slant. Slope is less here. Okay. Suppose zero slope, slope increasing like this. Okay. So according to that, slope of the P2 is greater. Therefore, P2 value will be, pressure at the P2 will be lesser. Okay. So this is how you have to analyze your graph in the states of matter chapter. Okay. So this is the most important points of the Charles law. Okay. Now let's see the further. Next is the GAYLUSSAC'S law. Okay. So in the GAYLUSSAC'S law, it is related to, as I told you, what? Pressure, volume, temperature, and number of moles. Now we have related these two in which law? Boyle's law. Okay. We have related these two in which law? Charles law. Now let us see what is related. Okay. In this, we are going to relate with the pressure and temperature. Okay. What we are going to relate? Pressure and temperature. Okay. So let me erase and give you the clear look. Okay. Pressure, volume, and temperature. Okay, this red color will show the Boyle's law. Now let me take blue color. Okay, so blue color will show the Charles law. Okay, this blue color is about the Charles law, and this red color is shows the Boyle's law. Okay, now I will take green color. Then green color will show the uh, Gay-Lussac's law. Okay, so Gay-Lussac's law, pressure and temperature. Pressure and temperature. Okay, this is what Gay-Lussac's law. Gay-Lussac's law. Okay, then one more thing is left over, that also I will cover it here itself. I will take purple color, volume and number of moles. Volume and number of moles with the Avogadro's law. Okay, Avogadro's law is related to volume and number of moles. Okay, now let's see the further. So first in this session, pressure and temperature relation. Okay, in the Gay-Lussac's law, pressure and temperature. Simply when you heat any gas, you will find increase in pressure in your daily life also. You can understand when you heat the water, then the lid over that container will come down, because when you are heating, the gaseous pressure will increase, so that lid will come down. Okay, that the lid will fall down because of the temperature increase, pressure is increased, therefore number of collisions on the lid per unit time will increase, therefore pressure will increase. Okay, so once we say P, pressure by temperature is constant. Okay, so P direct proportional to T, then we can say P by T is equal to constant. So P1, P2, same way we can write it here, P1 by T1 also K, and P2 by T2 also K. Okay, so then what we will do, we will combine both of them. P1 by T1 is equal to P2 by T2. P1 by T1 is equal to P2 by T2. Okay, now here what we are maintaining constant, volume we are maintaining constant. Therefore the graphs obtained in this are called as a isocores. Okay, now here same type of question, but by this time you are comfortable. First what we will see, which is greater or how it is greater, what we will see, we will write the PV is equal to nRT first. What we will write, PV is equal to nRT first. Then we wanted to convert this into Y is equal to mx plus C form. So P should be on Y axis, T should be on X axis. So P is equal to nR by V into T. Okay, so here P and slope is represented by nR by V. Okay, same problem with the pressure and volume. Okay, slope is inversely proportional to volume. high slope, see here it is slant up. Okay, so high slope means volume is lower, low slope means volume is higher. Understood? So this each line is called as isocar. This is isocar, this is isocar. How many isocars we have? We have the three isocars V1, V2 and V3, and each isocar representation slope value will depend upon the volume. With the gas which is having less volume will have the more slope, more volume will have the less slope. Okay, so that is what the relation between the graph and the slope. Okay, then in PT curve, an isocar with lesser slope will have the higher volume. This is what already given. Okay, now it is about the Gay-Lussac's law. Three laws we have studied. What are the three laws? Boyle's law we have studied, Charles' law we have studied, and Gay-Lussac's law also we have studied. Now let's see the further. Okay, so as of now, whatever we have studied, three laws. Now let us consolidate them. Okay, so after consolidating all the three laws together, we will get a equation which is called as a combined gas equation. What it is called as combined gas equation. Combined gas equation is a combination of how many forms? Three forms. Combination of how many forms? Three forms. Okay, we are combining the Boyle's law, and we are combining the Charles law, okay, and we are combining the Gay-Lussac's law. So when you combine all of them, we combine all of them, then we will get the formula combined gas equation. You can ask how sir it is, okay. So simply, if you take only numerator, okay, so I will tell you how to derive the all the three formulas from this, okay. So during Boyle's law, what we said? During Boyle's law, we said that T is constant. Okay, from this law, Vp by V by T is equal to constant. Okay, so therefore PV is equal to T into constant. T into constant. Okay, so PV is equal to K. That means PV is equal to constant. Is that clear? Now this is Boyle's law. It shows that it is a Boyle's law only. And once I say combined, so it should be other two laws also. So once this is during the Boyle's law. Now let me show you how it is other law also. Okay, for that let's go to the whiteboard now. Okay, so in this law, Charles law, PV by T is equal to constant. PV by T is equal to what? Constant. Okay. Now PV for making the relation, we will take only V by T. Okay. So then it will become as V by T is equal to constant by pressure. Okay. So if we keep during the Charles law, pressure also constant. So V by T is equal to constant, new constant. So that means it is a Charles law also. Charles law also proved. What is Charles law? V by T is equal to constant. And now let's prove the third law. What is that? Pressure by temperature. Okay, this is Charles law. Charles law proved. Now let's take the another law, that is called as a Gay-Lussac's law. Okay, in the Gay-Lussac's law, PV by T is equal to, now this is what combined gas equation. Okay, now in this equation, what we should maintain, additionally we can keep what constant? Yes, volume should be constant. Okay, what should be constant? Volume is constant. Then P by T is equal to constant by volume. So P by T, okay, is a constant by another constant for some time, then it is called P by T is also constant. So this is Gay-Lussac's law also we have derived. So PV by T is equal to constant is a combined gas equation of Boyle's law, Charles' law and Gay-Lussac's law. Okay. So we can also write it as a P1 V1 by T1 is equal to P2 V2 by T2. This is the formula of the Charles' law. Okay. Note down this. Okay. After the combined gas equation. Okay. As I told you, total how many laws are there? There are four laws, but as of now we have studied only three laws. Now we are going to study the fourth law. And what about already I have given you in the introduction itself. Okay. Pressure, volume, temperature, number of moles. We are left with only volume and number of moles. Okay. Now, there is a surprisingly different concept here. Okay, what is that? Equal volumes of all gas contains equal number of molecules. This is very, very important. Equal volumes, equal molecule. Okay, at the same pressure and temperature. It is not that hydrogen gas is very small, so we will get more molecules in 1 liter, not that. Okay, we will get same number of molecule, so we will not get more number of molecules in small molecule, or we will not get less molecule if it is a big molecule. So irrespective of size, equal volume, suppose 1 liter is there at constant pressure, at constant temperature, at given point of at given pressure and temperature, 1 liter will always contain same number of molecule. Let it be hydrogen also, let it be nitrogen also, let it be even sulfur dioxide also, but pressure and temperature must be same. So that is what Avogadro's law says. But it is molecule, not atoms. Okay. So let me tell you with one example so that you can clearly understand. Okay. So what is that example? I will take STP condition. Okay. What I will take? I will take STP condition. In STP condition. Okay. STP means already I told you standard temperature and pressure values also I have told you. So at STP condition, I have taken 22.4 liter, 22.4 liter of oxygen. Okay, then ozone and then sulfur trioxide. All of them are 22.4 liter only. Okay, and all of them are at standard temperature and pressure only. Then number of molecule, if question is about number of molecules, okay, then this will also contain Avogadro number of molecule. This will also contain Avogadro number of molecule. This will also contain Avogadro number of molecule. But it is not permitted to number of atoms. Number of atoms can be more or less. In oxygen, 2 into Na. Why? Because its atomicity is how much? 2. Okay, its atomicity is how much? 2. So once I write O2, so each molecule, this 2 you have to multiply here. Same way now, can you say what is for ozone? What should be multiplied by for ozone? Okay, here for ozone, what we will do? Its atomicity is 3. So it will be 3 into Na. And here atomicity is 4. Two different types of molecules are there, one sulfur, 3 oxygen. So therefore it will be 4 into Na. Okay. So this is the number of atoms are not same, but number of molecule will be same. Okay. Irrespective of the size, equal volumes of all gases contains equal number of molecule, but may or may not be equal number of atoms. It is not that I am not saying that every time there will be different. Suppose in this place, in place of the oxygen, if I keep nitrogen also, if I keep what? Nitrogen also, that time also that number of atoms will be same because their atomicity is same. So main problem comes with atomicity. If atomicity is same, the number of atoms also same, number of molecule also will be same. So this is what our which law says? Yes, our Avogadro's law says. Okay. Now, how it is proved and what is the mathematical formula that we are going to see now. Are you able to see on your screen? Okay. Now it states that equal volumes of all gases at the same pressure and temperature have equal number. Now I think it is more clear to you about this sentence. Okay. Now if we know that one mole contains these many molecules, it is obvious that two gases contain equal number of molecule. They must also contain same number of moles also. Okay. Suppose at a given pressure and temperature, volume of any gas also proportional to number of moles. Second law. Okay. Actually, there are two parts: equal volumes, equal number. That is one part. Second law says that at constant temperature and pressure, volume is directly proportional to number of moles. Volume directly proportional to number of moles. Okay, this is another form of the Avogadro's law, and this is what mostly used. Okay, so at a given temperature there must be contain these many. So at STP, volume is 22.4 liter or 22,400 liter. So this 22,400 liters only called as a molar volume. What it is called as molar volume. Okay. So Avogadro law can be used for determination of molecular mass. That is the one of the advantage of our Avogadro's law. Okay, 1 mole of any gas at STP, 1 mole of any gas at STP will occupy 22.4 liter. This is already we have understood now, and we can use it for molecular weight. So suppose they are giving 10 liters, this many grams, 33 grams, then find out its molecular mass. Simply what you will do, if 10 liters 33 gram, then 22.4 liter will be how much? So that how much is only the molecular mass, because any gas will contain 1 mole molecule. 1 mole molecule mass is called as a molecular mass. So you let them given with the volume at any condition, at any mass. Okay, any volume they can be given, but by using that volume you will convert the mass of 22.4 liter. Then that mass of 22.4 liter will be converted into molecular mass. Okay, so this is another formula, or you can say this concept only covered over here. Okay, so whatever the volume given at STP you will substitute here, whatever the mass given you will substitute here, and MO is also units will be gram per liter into 22.4 liter. Molecular mass also can be determined if you are given with density and you have to multiply it with 22.4 liter. Then you will get the molecular mass. These are the two different formulas. Density given second formula, mass given first formula. That's all. Okay. So this is about what? Avogadro's law. Okay. Now we got another law introduced. Now we are going to combine how many laws now? 4 laws we are going to combine. If you combine only 3 laws, that is not ideal gas equation. Most of the students are having wrong concept that ideal gas equation, combined gas equation, both are same. No, ideal gas equation is combination of 4 laws, whereas combined gas equation is combination of only 3 laws. Okay, here we are adding the 4th law. What is that 4th law? Avogadro's law also we are adding. Okay, so then PV is also equal to, up to here it is combined gas equation. Now we are adding the third equation, PV by T is equal to NR. Okay. Now what is N here? Number of moles. So PV by T is equal to NR. Then number of moles also introduced over here. Then we can say PV is equal to nRT. This is what we call it as a ideal gas equation. Now, most of the students, those who entered into the class 11th or first year, they all know the PV is equal to nRT, but very common problem. Okay, what is the common problem they are facing? They are facing the units of. Okay, so suppose this is the shape of a student. Okay, so till the time you make them understand about the concept, they are very happy. Okay, so but by the time you ask them the question related to the units of universal gas constant. Okay, so then they will become like this. Okay, how to remember, sir? Okay, so but after this trick or after this lecture, now they will start, their face expression will become like this. Okay, so before and after, this is a change in expression of line. Okay, convex and concave in the physics. Okay, so what is the common problem people are facing? Units of a universal gas constant. Okay, so that tips we are going to study now. Universal gas constant, I think everybody noted and no problem, but we are going to study values of R. Okay, so here units of R, if you wanted to know only unit R, R value should be kept left side, remaining values kept right side. Now, when pressure is in atmosphere, volume is in liter. Okay, liter atmosphere. Denominator is always same. Okay, so for pressure it is atmosphere and volume is in liters. Okay, divided by number of moles only you will be given with, and temperature should be must be in Kelvin. Then the R value you have to substitute is 0.0821. This is constant. When pressure atmosphere, volume liter 0.0821. But when pressure is in Newton meter square, this is also called as Newton meter square is also called as, in the previous lecture only we have studied. Okay, 1 Newton meter square is also called as Pascal, and we have the relation between pressure and Pascal also, pressure and Newton meter inverse, ATM and Newton inverse also called. Mainly volume should be in meter cube. Here we meter square and here meter cube. Then only it is changed into 0.081 changed to 8.314. Okay, and this R is equal to 2 for liter per mole. Okay, Kelvin. Simply what you will remember these values at least 0.0821. Okay, so but you will mention that pressure should be in ATM, volume should be in liter. 0.0831 also no problem, by 8314. Okay, so but that pressure will be changed to, from atmosphere there was pressure, the previous way pressure was ATM, but now we have changed into bar, then this will be the units. Okay, sorry, if pressure is in bars, then value of the R will be 0.08314. Okay, and energy question, once there is a energy question, try to write 8.314. Okay, 8.314, not 41, it is going to mistake. 8.314. Okay, now 8.314 is the energy, but if it is molecular mass is something else, then you will, what you will do, divided by molecular mass. Okay, so pressure energy is 8.314. Okay, next, if it is in joules, when it is in joules. Okay, next, if it is in calorie, R value, then what you will do, calorie per mole Kelvin, mole inverse Kelvin inverse. And if you need to convert, simply you can multiply it here with this, you will get how much, 8.314. Okay, this is the conversion factors. R value, remember pressure ATM 0.0821, pressure bar 0.08314, energy question joules, then 8.314, energy question calorie 2. Okay, So this is how R value, 4 values are sufficient. Okay. Energy 2 and pressure and liter ATM to others 2. And change them into this unit. If they are given, suppose 760 mm is given. Okay. Now there is, we don't have the units for centimeter. We will use divided by 760. We will use by divided by 760. Okay. Then you will get it. Okay, 760 by 760 watt, you will get 1 ATM. So then we will use units according to this. Is that clear?